Hello, so today we are going to do this problem called lucky numbers in a matrix. So the problem says we have an n by n matrix and we want to return all lucky numbers in that matrix in any order. And the lucky number is an element of the matrix such that it is the minimum element in its row and maximum in its column. So minimum in a row, maximum in a column. So we have this matrix here, and 15 is the only lucky number since it's the minimum in its row, this row here, and it's the maximum in its column. Okay, so that's what we are looking for. It doesn't say if we are guaranteed to have one. It does say that the elements are all distinct. So let's see. So we could just take the minimum of every row and the maximum of every column, and then since the elements are distinct, we could take the one that is in both, right? Okay, so that would mean let's first just have the bounds. Let's call this M, and then let's call this M0. And what we are looking for is to get the minimum of every row, right? So rows min, and then we need columns, and then we will need to go through the rows. So for rows min dot append, and we'll take the min of the row, which is just actually we could just do row in M, and we could just take the row min, and we could do something similar for the columns. So for j in range of columns, so from every row we'll take and then for I in range of, or for row in M, what we will do is cos max actually here. So maybe we could do cos max dot append row j. But we want the columns max, right? So we'll have this column here, so column max. Let's just take the first row. So the size is at least 1, right? So what this means is that we could just start from something that is really small, right? So that would be like this maybe, and col max would be equal to the max of this. And then once here, we could just append it. We could append and now that we have both, so one thing I'm thinking we could do is instead of just going through both lists, we could just turn them into a set. So let's say I have rows min to be maybe a list of 14, 2, and 4, and then columns max to be equal to 14, 1, 5. Actually, let's make this a set. So if you make this to be a set and do a similar thing for max, make it a set, then when we do rows min, we get the rest, everything except the, so if we do the difference, So this gives us one, so it gives us everything except the so Python intersection of sets. Okay, it's just intersection. So we could just say rows min dot intersection and columns max. Yep, that gives us the element. So we could just return rows min dot intersection with. We could also just check if it's in rows min, right? So if we make this a set, and then potentially also just make this one a set. Oh, it wants all lucky numbers. Okay, so it wants all of them, not just one. And so let's just have a list lucky like this. We actually don't need to do this again, right? And we also don't need to do this. So what we can do instead is keep track of the rows mins, but here, when we find a column max, we could just check. So if this max is in rows min, then we could just add it to the lucky numbers. And here this should be add. Okay, that looks good. Let's try it on this one. Okay, that works. Let's try it on this one too. Okay, so that seems to work. Let's submit. Okay, so that passes. So all I'm doing here essentially is finding the rows min values and then going through the columns and finding the max of each column. And then if that max is already in the rows min, then it's a lucky number, so I just add it. So pretty straightforward. Let's see if there is a better solution. Yeah, okay. Yeah, some people, instead of calculating the columns max in the way I did here, they like zip them. Doing this basically makes the columns become rows and the rows become column, and so that way it gives us an easy way to get the columns in a similar way to the rows, right? Because let's say if I have this matrix, and if I zip and so if I do this and make it a list, you could see here 3, 9, 15, and then 7, 11, 16, and then 8, 13, 17. So it becomes, the columns become rows. And so if we do that here, if we change this to make that happen, the way it would look like is, okay, we have this, and then here instead we can just say column in range, in zip of star m, and then that way, instead to get a column max, we could just say it's the max of column, and that should give us the same thing. It does, right? And so with this, we actually can even make this shorter actually, because we don't need this rows columns thing here. And also we can just use set intersection that I mentioned earlier. So instead of doing all of this, we could just say something like, what we want is basically the set of min of row, right? Min rows for row in M, right? And then we want the set of columns, right? Of max of the max of the columns, right? So that would be column for column in. Since we could just make the columns rows using this, we could just do that like this. And now we just need the intersection between these two sets. That's the list of the lucky numbers, and we could just return that. So you can see here it's still everything is good. So let's submit. Okay, so that works too. Yeah. So a set of the minimum of the rows and min of columns, and we could just return that. Yeah. Okay. I think these two solutions are good enough. Yeah. See you next time.